Simple pendulum. Simple pendulum is an example for law of conservation of energy, mainly because this is the body whose energy can either be potential or kinetic, or potential and kinetic, a mixture of potential and kinetic. But at the same time, at any instant of time, the total energy of this body remains the same. So that is what the law of conservation of energy talks about. So this is a very good example for understanding law of conservation of energy. Now let us see how the simple pendulum works. So we have a rigid support and there is a thread hanging to the support with a metallic bob at the end. So this is a metal bob. Now this metal bob swings along its centric position. So let us say the center position is position A and both the extreme positions we will call it as B and C. Now what happens? Initially when the bob is at rest, that is at the center position A, what happens? We pull the bob from the center position to a certain length and release it from B. So bob is pulled to one side, that is to position B, and then we release it. Once this is released, then it starts swinging alongside of the center position A. So when it starts swinging, the other position to the other side of the center position, that is C. So the bob starts swinging between B and C along A. So what we did basically, initially the bob is at rest in the center position. Then we swing the bob to position B and the oscillations takes place. Oscillation is nothing but one movement from B to C and C to B. From B to C along A. So it goes from B to A to C and C to A to B. So these oscillations just continue to take place. Now what happens? Let's examine about the energy. When it is at position B, when we pull the string and hold the metal bob at position B, there is only a potential energy with the bob. So what happens at position B? Bob has only potential energy. Now you release it. When it is released, it will start gaining kinetic energy. How will it start gaining? This potential energy gradually gets converted into kinetic energy. So basically when it is at B, it has only potential energy. Whereas when it is moving from B to A, it has both potential plus kinetic energy. Because the potential energy gets converted gradually into kinetic energy. The moment it reaches its center position, then it will have only kinetic energy. What does it mean? The entire potential energy got converted into kinetic energy by the time it comes to the center position. So at position A, the bob has only kinetic energy. Now again it starts swinging from A to C. What happens here? This kinetic energy gets converted into potential energy. Gradually it gets converted. So in this path, it will have potential energy plus kinetic energy. But by the time it reaches the position C, then the entire thing will become potential energy. So it stops for an instant of time at C and again starts moving back towards A and B. So this is how the oscillations takes place and energy gets converted. But what we need to note is that the total energy of this swinging pendulum at any instant of time remains the same. So we said at position B, it is only potential energy. And then in the intermediate positions, it has potential energy plus kinetic energy. At position A, the whole potential energy got converted into kinetic. And from A to C, when it goes, again at C, it has only potential energy. So what does it mean? Total energy of the swinging pendulum at any instant of time remains the same. That means it is conserved. So from this we understand that the total energy of the swinging pendulum at any instant of time remains the same, that is conserved. Either it is in the form of potential energy, or it is in the form of kinetic energy, or it is in the form of both. And the pendulum keeps oscillating for some time and then comes to rest. Does it keep oscillating forever? No. It keeps oscillating for some time and then comes to rest ultimately. And why this happens? Because of the friction, the supporting point, at the supporting point of the pendulum, air friction. When it is moving in the air friction. So these two act on the swinging bob, and that converts this mechanical energy of oscillations to heat energy. So it takes some time for this mechanical energy of these oscillations to get converted into heat energy. That conversion happens because of the air friction and the friction at the support. So once it gets converted into heat energy, what happens? That heat goes into the environment. So the energy gets released. It's consumed by the environment. Once the energy gets consumed, then the pendulum comes to rest. Pendulum comes to rest ultimately after oscillating for some time. And what makes the pendulum comes to rest? It is the frictional force acting on the support system as well as the air friction. Both together converts this mechanical energy into heat energy, and that gets into the environment. So basically what we understand from this swinging simple pendulum is the energy at any instant of time during the oscillations remains the same. And this is the principle that is used for constructing the mechanical watches.